This assignment is so important, but it's where I think most people get confused with the algebraic parts of calculus, and that's the manipulating of the algebra to make it do what we need it to do. So how could we rewrite this in order so we can use the product rule? So there's different ways we can rewrite this. Personally, I would do the power rule. And let me show you how to do the power rule. This is asking for the product rule, but if this said the power rule, which is, the typical one where if you have x to the third, you bring it down as 3x squared, right? Well, since all of these are being divided by x, you can divide them each individually by x. You have to do it with whatever the denominator is. So this, what I'm going to show you, doesn't work for this one because it's x minus 7. You'd have to divide each term by x minus 7, which really doesn't do anything. But when you have a monomial, it's actually quite easy to divide all the terms by x. This here is the exact same thing as 2x cubed over x minus x squared over x plus 5x over x, which would give you 2x squared minus x plus 5. Now that is for the power rule, because now we can use the power rule on this. So that would be A if this said power rule. And that's honestly the way you should handle that problem. By the way, that, like I said, doesn't work for this problem over here, because we would have to divide each of these by x minus 7. So 5x over x minus 7. And that does not really help us at all. That doesn't help us take the derivative. It's still just a bunch of quotient rules after that. So no purpose in that. But when it's a monomial, like I said in the denominator, you can divide each individual one. And it will simplify to a point that we could use a power rule. But for the product rule, all we're going to do is bring that x up to the top as x to the negative 1. And now it's the product of two functions. So hey, we're going to go with B, because it's the product rule. So we can take the derivative of this using the product rule. This is f times g, so f prime times g plus f times g prime, and so on. This right here would be power rule. So once again, just pay attention to what the question is asking. Let me just put this in green just so we can distinguish the difference. Looking at that, it'll stick out a little more. So we want the product rule. This one, how would we do this? I'll give you a list of steps after this video. I just want to show two examples in the video. How would we rewrite this one for the product rule? So once again, this one's asking for the product rule. So we would just bring that x up to the top as x to the negative 1. So it would be c, x to the negative 1 times square root of x. Now I'm going to tell you again, that's not the way I would do it. I would set it up for the power rule. Once again, a little bit easier, but I'm going to show you how to do that. It's your choice. It'll still get you the same derivative, but do you really want to be dealing with the product rule? So power rule, we rewrite this square root of x over x as x to the 1/2 over x. Subtract the exponents, and you end up with 1 over x to the negative 1/2. I mean, not negative 1/2. X to the... Which we can't use the power rule on that exactly. So we got to just bring that up to the top. It's x to the negative 1/2. So x to the negative 1/2, that we can use the power rule on. Which isn't an option here, but like I said, that's the way I would take that derivative. That's the route I would go with that. So sometimes, I'm just showing you, sometimes we need to rearrange these and rewrite them in a way that's easier to take the derivative for us. I mean, this is a way. We could do the product rule on this. That is one method. This would be a little bit easier though. And then, I know I said I wasn't going to go into the problem, but this one, how can you rewrite it for the power rule? Currently it's a product rule. There's no way we can rewrite this. We can't somehow put one of these, I mean, there's a cosine. How are we going to use the power rule? So this is not possible.